Welcome back to DigiTutorials. Today we're tackling trigonometric equations. Think of them as puzzles where the unknown is inside a trig function like sine, cosine, or tangent. Instead of solving for x, we're hunting for an angle, often called theta. For example, if sine theta equals 0.5 comma, we ask what angle gives that value. One answer is 30 degrees, but here's the twist. There are infinitely many solutions because angles repeat every 360 degrees. So, 150 degrees and 390 degrees also work. The first step is to find the reference angle, the basic solution, usually in the first quadrant. Then, use your knowledge of where sine, cosine, or tangent are positive or negative to find all solutions within 0 to 360 degrees. For sine theta equals 0.5 comma, the answers are 30 and 150 degrees. To get every possible answer, add or subtract multiples of 360 degrees. Theta equals 30 plus 360n, and 150 plus 360n, where n is any integer. That's how we capture all solutions, just like wrapping around a circle. Trigonometric equations are just puzzles with a few extra twists. Let's see how they get more interesting. Now let's level up. Trig equations come in different degrees, just like algebra. Degree 1 equations have the trig function to the first power, like 2 cos, theta, 1 equals sine 0. Solve it by isolating the trig function cos theta equals sine 0.5 comma, then find all angles that work. Degree 2 equations have the trig function squared, like sin 2 theta, 1 equals sine 0. These look like quadratics, treat sin theta, or cos theta, as a variable. For example, 2 cos 2 theta, cos theta, 1 equals sine 0 becomes 2x2, x minus 1 equals 0, factor it, 2x plus 1, x, 1, equals sine 0, then substitute back, cos theta, equals sine minus 0.5 or 1. Now solve each simpler equation as before. Degree 1, isolate and solve. Degree 2 factor, then solve each part. Recognizing these patterns makes trig equations much easier. Let's see how to handle even trickier cases. Sometimes trig quadratics won't factor easily. That's when the quadratic formula saves the day. For an equation like 3 sine 2, theta, 5 sin, theta, 1 equals sine 0, let x equal sine sin, theta, plug into the formula x equals sine, b plus skart b2, 4ac. 2a, calculate the possible values for sin theta. Discard any impossible values, like those outside minus 1 to 1. For valid solutions, use your calculator to find the reference angle. Then all possible angles in the required range. The quadratic formula guarantees you can solve any trig quadratic no matter how messy. It's a powerful bridge between algebra and trigonometry. Why does this matter? Trigonometric equations describe anything that repeats: waves, cycles, rhythms. Tides rise and fall in predictable patterns, modeled by trig equations. Crucial for shipping and coastal engineering. Sound waves in music are shaped and filtered using sine and cosine functions. Even your heartbeat, measured by an ECG, is a repeating wave analyzed with trigonometry. Solving trig equations helps us predict, analyze, and control these cycles. From navigation to medicine to music, trigonometry is everywhere. It's not just math, it's the language of the world's rhythms. Let's see how these waves are built. Sinusoidal functions, sine and cosine waves, model real-world cycles. The general form is y equals sine a sin, bx and c, plus d, or y equals sine a cos, bx c, plus d. D shifts the wave up or down, a sets the amplitude, b controls the period, and c shifts it left or right. For tides, d is average sea level, a is how high or low the tide goes, b sets how often tides repeat, and c tells when the cycle starts. Adjusting these values lets us model anything from ocean tides to sound waves. Understanding these 4 parts lets you describe and predict any repeating pattern. Sinusoidal functions are the foundation for modeling the world's cycles. That's the real power of trigonometry. If you find this video was useful, please share with your peers. Have a great summer and see you in the next school year.